In this video, I'm going to go over what are the assumptions that underlie an independent samples t-test. Every statistical test is based on some assumptions, some things that we agree upon that need to be in place. So let's take a look and see what these are for this particular test. So in this section, I'm going to talk with you about the assumptions of independent samples t-tests, and one that we're really going to focus on is the assumption of homogeneity of variance. So the first assumption of an independent samples t-test is that observations within each sample must be independent. So what does this mean? It means that I can't be a member of both group A and group B, or sample A and sample B. Each member of the sample must be independent of the other sample. So you can't have somebody with group membership in both samples. And populations from which the samples are selected must be normal. We've talked about that too. We've also talked about how with sample size, we can not worry so much about this. If we have a sample size over 30, the distribution approximates a normal distribution. But the third one is more problematic, and this is populations from which the samples are selected must have equal variance. So what does that mean? If we look at the variance within sample A and within sample B, we are going to assume for doing this test that they're about the same, that the scores vary in about the same way in each different distribution. So why does this matter? Well, most hypothesis tests are built on underlying assumptions. The tests usually work if the assumptions are violated, but one notable exception is this homogeneity of variance. It really does affect the actual results of the independent samples t-test. So this assumption requires that the two populations from which the samples are obtained have equal variance. I'm just repeating that. And why this is critically important is it's necessary to justify pooling the two sample variances. We spoke in the previous video about pooling sample variance, and that's how we get to our standard error of the mean differences. And using the pooled variance in the calculation of the t-statistic assumes that those variances in each sample are equal. If the assumption is violated, then the t-statistic contains two questionable values. So first of all, the value from the population mean difference, which comes from the null hypothesis, comes into question if the variances are not equal. And the value for the pooled variance comes into question because is it really an equal pooled variance, or is one sample overly weighting the variance? Maybe one sample has a lot of variance and it's affecting the pooled variance. So if variance is unequal, you can't determine which of the two samples is responsible for the t-statistic that falls in the critical region. So one sample may be more responsible for the difference that is being seen. And you can't be certain that rejecting the null is correct when you obtain an extreme value for t. You don't know if it's really true or if it's manufactured by this unequal variance that's happening. And it may lead you to make the wrong statistical decision. So this is something that we can test for when we use statistical software. We can test to see if our variances are equal enough that we can be confident in our results. So in the next video, I'm going to lead you through hypothesis testing with an independent samples t-test.